Hey everyone, welcome to the video on density and specific gravity. Alright, density is a physical property and it relates the mass of a substance and its volume. So it actually has a mass and a volume unit, which can be very useful even when we are trying to convert from one unit to another. So density equals mass over volume. So it's mass in grams and volume in milliliters. And remember, a cc is just a cubic centimeter, so centimeters cubed, or cc. That's the same thing as 1 milliliter. This is useful, so if we have the volume of a substance and we want to find the mass of it based on its density, then we can do our one-step conversion using the density, since it uniquely has a mass and a volume unit. So if we were given the milliliter, we had 1 milliliter, and then our density, let's just say, was 1 also gram per 1 milliliter. Okay, so we consider whenever we write out a number such as 1, so the density of water is 1.0 grams per milliliter. Okay, we consider that milliliter to be a 1. So if you want to write a 1 there, you can. Okay, and so then you could just multiply, units cancel, and get your grams. Okay, if you had a mass of a solid and you wanted to find the volume, then you could use the inverse of density. So so we could write it out 1.0 grams per 1 milliliter. We're just using 1 just for practice here. Okay, you can flip that over just like we've seen with conversion factors. Okay, and say that in 1 milliliter there's 1.0 grams. And if you do that, then your grams cancel and you're left with milliliters. So this is what is unique. Oops, didn't mean to do that. Okay, this is what is unique about density, is that it has that mass and volume unit. Okay, and we can get from one to the other using it. Okay, so if the density of acetic acid is 1.05 grams per milliliter, or 1 milliliter, what is its volume of 5 grams? Okay, so what we're going to do is our original quantity, we always write out what we know first. That's what we've been talking about through the semester so far. Okay, and we're looking for milliliters, but in this case we're not given a conversion factor per se like from a table. We're going to use our density because that's our common relationship, because it has a mass and a volume unit, and we're trying to go from mass to volume to milliliters. Okay, so density is the conversion factor. Okay, so it's not like our typical 12 inches in a foot or whatever. Okay, so we can write it as 1.05 grams in 1 milliliter. So all I'm doing is taking this. Okay, or you can flip it over and you can write it as 1 milliliter per 105 grams. So same thing, you have two fractions that you can use. Okay, and guess what? Exactly like we've been seeing, you're going to make your units cancel. So that's how you plug it in. You plug it into the equation to make your units cancel. Okay, so we're going to have to use the inverse density here, okay, because if you set up the problem to solve, 5 grams, that's what we're given. This is our given. Okay, you need to cancel with grams in the denominator. Therefore, we have to put that 105 on the bottom and 1 milliliter on top. Okay, and then we get this really long number, and we know that we can't report all those numbers because we did not measure precisely enough to do so. So we have to go look at that given number. That's our measured number. Okay, a density is an exact number. That's a physical property, okay, of it. So we have 2 sig figs there. Okay, there's our canceling, like I mentioned. Okay, and now our sig figs, we have 2, and so we have to have 2 in the answer. So we round that 4.7, has a 6 next door, So we round the 7 up to an 8 and drop all the numbers beyond that. All right, another term, so density and specific gravity are two very similar concepts, but they are different. Okay, specific gravity is a quantity that compares density of a substance with the density of water at the same temperature. Okay, so temperature is the main thing here because typically, and for this most of your problems and for most of this beginning chemistry course, the density of water is 1. Okay, so it sort of seems funny here because if you take the specific gravity and you take the density of a substance divided by the density of water, if water's 1, then the specific gravity is the same number as your density of a substance. So if, let me just say for example, we have a density of an object that is 4 grams per milliliter, okay? And we want to find the specific gravity of it. Specific gravity just means divide by the density of water. Well, the density of water is 1, so my specific gravity is the same. Okay, the only difference here is specific gravity has no units because look, my units cancel each other, okay? And they leave you with no units. All right, so specific gravity and density are very similar, except specific gravity, you take that density and divide it by the density of water, which is typically 1. Now, if you're given a different number because the temperature is different, then you would plug in that number for the density of water. Okay, and so the big difference here is it has no units, and all the numbers we've been reporting have had units when we measure, so that is a big difference for us. Okay, I want to do just a couple simple problems just to see that we can come up with density of an object. Density is mass over volume, and more specifically is grams over milliliters or centimeters cubed. Okay, and so here we're just straightforward plugging in 2 numbers to get density. So we want to know the density of a substance that is 742 grams. So I could take this substance or object, put it on a balance, and get the mass. Okay, and then the volume that it occupies is 97.3 centimeters cubed. That's the same thing as a milliliter. So if you want to use that, you can. So we'll use milliliter. Okay, and when you do the math there, I think I have it written down, we need 3 sig figs. We've got 3 sig figs in both the numerator and denominator. And now my unit, since its density, is grams per milliliter. So this object has a density of 7.63 grams per milliliter. All right. This problem down here is wanting you to use the first operations that we talked about in this video. It's where you're given the mass. Okay, here it's a liquid. And we're going to look for volume. So once again, you're going from a mass unit to a volume unit. Okay, and to do that, we're given density. So this is our conversion factor. Okay, so we take 125 grams. Okay, and we have to plug it in so that grams cancel. So the grams is going to have to go down here. And then that milliliter is an understood 1. So we take 125 and divide it by 1.32, and we get, units cancel, 94.7 milliliters. Okay, I'm going to take this one step further. So here's my answer for number 2. I have 3 sig figs to start with. I have 3 in the answer. Okay, I'm going to go back up here and let's look at this 7.63. That's the density. Okay, if I were to ask you what's the specific gravity of this substance here, okay, then I would say, okay, I have my density, 7.63 grams per milliliter. Okay, and we'll say the problem tells us that the volume of or the density of the water is 1.0, or 1.00, we'll say. Okay, then the specific gravity, units cancel, is exactly the same as the density, just without units. All right, I hope you understand the density and specific gravity, and I will see you later.